All right, today we're going to take a look at the elimination method, and we're going to use it to solve word problems. All right, so what we got here is that Kristen spent $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. If she bought a total of 7 shirts, then how many of each kind did she buy? Guess and check is not an option here. So what we want to do is we want to create this algebra equations. We're going to have 2 of them because we have 2 different types of shirts, fancy shirts and plain shirts. So what we're going to do is we're going to let F be the number of fancy shirts. And we're going to let P be the number of plain shirts. Now what we have in this problem is we have the quantity, the number of shirts that she buys. She buys a total of 7 shirts. And then we have costs that are affiliated with those 2 types of shirts. So first thing we're going to do is we're going to create an equation that tells me how many fancy shirts and plain shirts she bought that equaled up to 7 shirts. So our first equation is going to be F plus P equals 7. This tells us the number of fancy shirts plus the number of plain shirts equals 7 shirts total, which we see. All right, next, we're going to look at the cost of the shirts. Costs go together, so she spent $131 on all of her shirts, but the fancy shirts were $28. So if she bought 1 fancy shirt, it would be $28. If she bought 2 of them, it would be $56 because you're going to times the number of fancy shirts by the cost. So we have $28 times the number of fancy shirts. You don't need dollar signs in the equations because it just makes it look a little bit more messy, so keep them out till the end. Then the number of plain shirts she bought, we don't know, but if she bought 1 plain shirt, we know it would be $15. If she bought 2 plain shirts, it would be $30. If she bought 3 plain shirts, it would be $45 because we take the cost of the shirts, 15, and times it by the number of shirts, P, that she bought. But what we do know is the cost of the fancy shirts plus the cost of the plain shirts will total up to $131 that she spent. And this is our system of equations. Right now what we have to do is we have to actually solve this, and we use the elimination method because, as you can see, both variables are on the same side and they equal to a value on the other side. So it looks like it's in standard form. So what we're going to do is we're going to take our fancy plus plain shirts, which equals 7, and our cost for the fancy plus our cost for the plain shirts, which equals 131, and we're going to solve this by the elimination method. All right, so I'm going to take the words away for a minute. That way we can focus on our equations. All right, so now you have to decide if you want to eliminate F or P. I'm going to choose to eliminate P in this equation because it's a lower number. Okay, 15 is lower than 28. Now I need the coefficients in front of P to be opposite signs. Right now they're the same, so I'm going to have to multiply by a negative so I can force this to be an opposite of a positive. But I also want the coefficients to be opposite coefficients, so I have to multiply by negative 15. So I'm going to distribute that negative 15 on both sides, so I'm going to get negative 15F minus 15P equals, and then you multiply negative 15 times 7, and you're going to get negative 105. Okay, so rewrite your second equation. Always rewrite it so they're right stacked underneath each other and all lined up. And we add down the columns. So negative 15 minus plus the 28F is going to give us a 13F. Negative 15P plus 15P are going to go to 0. Keep your equal sign. Negative 105 plus 131 is going to give us 26. Then continue solving for fancy shirts, which is the F, and we get F is equal to 2. So this means she bought 2 fancy shirts. Okay. So I'm going to keep a little ledger over here. So far we know she got 2 fancy shirts were purchased. Now we need to find out how many plain shirts. Always go back to your original equations, and the original equation that is the easiest is the F plus P equals 7. So we'll set F plus P equals 7, and substitute in the number 2 for fancy shirts. Okay, so you're going to put this in here. So 2 plus P equals 7. Subtract the 2 on each side, and the number of plain shirts is 5. Okay. And I know it's obvious from the equation how many there are, but sometimes your numbers can be a little large, and if they are, you need the equation to set up and plug in so that you can calculate correctly. And that answers our question. How many fancy shirts and plain shirts did she buy? 2 fancy, 5 plain. All right. Next, different type of problem involving vehicles. Okay, a class of 195 students went on a field trip. They took 7 vehicles, cars and buses. All right, so cars and buses are our vehicles. Find the number of cars and the number of buses they took if each car holds 5 students and each bus holds 45 students. So what we're looking for here is the number of buses and the number of cars. So our first equation is going to be taken from here. If you took 7 vehicles and they were comprised of cars and buses, we're going to let C equal the number of cars and B equal the number of buses. So it's like keeping a little ledger on the side. So what we do know is the number of cars plus the number of buses equals 7 total vehicles. So that takes care of our first equation. Now we're looking at the quantity of how many students these cars and buses hold. And what we can see is that we have a total of 195 students that are going on this trip. And what we need to know now is how many students are in each of the vehicles. A car has 5 students. So if we had 1 car, we'd have 5 students going. If we had 2 cars, we'd have 10 students going. So we're going to take the number of students times the number of cars. So 5 students per car. 1 car, 5 students go. 5 and 2 cars, 10 students go. All right, now we're going to focus on buses. Buses hold 45 students. So 45 students per bus. 1 bus, 45 students. 2 buses, 90 students, and so on. And we know that there's 195 students that go. All right, so now we've got our system of equations. So we're going to take that, and I'm just going to rewrite it here so it's a little larger to see. So cars and buses equals 7 total vehicles. 5 students per car plus 45 students per bus equals 195 students. So I'm going to take this away now so we can just focus on our equations, and we're going to solve. So elimination process, because they're both in standard form, all the C's and B's on one side, numbers on the other. And I'm going to multiply my first equation by the lower number, because I think it's easier to work with lower numbers. And I want the C, I'm going to eliminate C, so I will multiply by -5, because I need the coefficients to be opposites. And that's a positive 5C, so I need this to be negative. So we get -5C. -5 times B is -5B. -5 times the 7 is -35. Rewrite your second equation. And we are going to add down the columns. -5C plus 5C goes to 0, and we've eliminated C like we wanted to. All right, -5B plus 45B is going to give us 40B equals -35 plus 195 is 160. Divide by 40 on each side, and we're going to get B equals 4. So what that means is they took 4 buses on the trip, and each bus held 45 students. Okay. Now what we want to do is we want to go back into the easier of the 2 original equations, and that would be the C plus B equals 7. So we had cars and buses equals 7 vehicles. Well, we know we had 4 buses. So C plus 4 equals 7. Subtract 4. And C equals 3. So that means they took 3 cars. So they took 4 buses and 3 cars to take all 195 students. Now, if you want to check these, it's very easy to plug in. Obviously, 3 plus 4 is 7. Then 3 times 5 is 15. 4 times 45, you would total that up. And then when you add them, you should get 195. Okay? And that is how you use the elimination method to solve word problems.